Hi there, welcome back to the channel. Welcome to another, possibly the final episode in the Back to Basics series, where I'm going into great detail in the restoration of this Nordmender Regulator 59. Now, this time we're going to tackle the FM RF alignment, and it's done in a little bit of a different way because I'm more concerned about stretching the dial to get a station which normally would not be picked up by this radio, rather than getting absolute accuracy on the dial. Does that make sense? The idea is this thing goes to 100 megahertz, as most of these old radios used to do. And my favorite station is actually on 101.6. I thought, well, another 1.6 megahertz, I'm sure we can stretch it a bit. And although it will throw off the actual dial alignment, I'm less concerned about that and more concerned with getting this thing to actually serve me. Okay, so let's get into it. This is possibly the final episode in this Back to Basics series. I'm not sure if I'll be doing any more. If anything really interesting comes up that I feel a need to describe, I'll probably do another one, maybe even two more in the series. So if you've been following the series and if this sort of thing interests you, stick around and enjoy the video. It's now time to tackle the RF alignment for the FM, and of course that deals with this scary box over here, the one that's shielded in the metal case, which should probably indicate you should stay out of it. This is to get the alignment of the stations corresponding to the dial. So if you're tuning into 100 megahertz, you want the station at 100 megahertz to come through. And of course, when you look at this little box over here, it is something that if you have any experience with this, you know you should stay away from, because when you open this up, all sorts of strange things can happen. Which means, of course, that when you make the adjustments, you have to be very, very careful, because some of these you should not mess with. The reason I say you shouldn't mess with some of them is because some of these settings here, some of the adjustments here are related to the whole stability of the circuit. Remember, this circuit is working in the over 100 megahertz range, the oscillator at least is, and because of that, it is susceptible to all sorts of things. When you work with frequencies like that, which are for the tube radio world, fairly high frequencies, for the microwave, they're miniatures, but if you're working with that, you're playing with components that are sticking out of the board. These components are big, so they've got physical size, they've got inductance, they've got capacitance, inter-component capacitance. This whole circuit is set up very carefully to take into account all those things. So you've got to be careful what you do here. And although there are some screw holes at the top that you can mess with, there are more openings than there are adjustments that a user or a restorer should play with. And let's see why. Well, if we look at the circuit here, this is the contents of that metal enclosure, the front end there. But effectively what we've got here is, again, two tuned circuits. There's the first one. That one there is the oscillator circuit. It's on the anode of the second triode of the ECC85. And that one there is the front end RF amplifier circuit, which is the job is done by this triode in the ECC85. So one tube doing the two jobs. It's a great circuit, this, used in many, many, many of these radios. Not all of them, but most of them. So here we go. We've got a front-end tune circuit which selects or pre-selects the area or the region of the station that you want to listen to coming in here. What's coming in here is the full FM range, and it's going through to this RF amplifier. It amplifies everything, but the only part that actually gets through and gets fed into the mixer over here is whatever you pre-select with this tuning condenser. This tuning condenser is what you tune when you're trying to select a station on your dial. This is half of the condenser, the other half is up here. Very, very similar to the AM example that I gave in the previous video. So you set your pointer to the station you want, and this over here will pre-select that with a bell curve. So it's not a sharp selection, it's actually quite a loose selection of the front end signal that's allowed to come into your mixer. The oscillator is sharper. That is the oscillator adjustment. Again, you can tune across the dial, and that oscillator frequency will vary from the bottom end to the top end because you've got this half of the tuning condenser that's being adjusted in harmony with that one there. Exactly the same as the AM example. Now you do have things here that you have to adjust. You have the tuning condenser that gets summed with this trimmer capacitor here. So this will adjust the actual capacitance of this tank circuit, and you have the tuned inductor, which again allows you to adjust to the opposite end of the dial. So you've got a minimum capacitance when your tuning condenser is wide open, in other words, unmeshed, and that gives you the highest frequency. And then you've got the lowest frequency when your tuning condenser is at the max, and that is fully meshed. And again, you've got these two adjustments to align it to the position that you want on the dial to give you the proper local oscillator frequency. Okay, now once you've got that, because you've got the 10.7 megahertz IF frequency that's been tuned all the way through, that is the only frequency that's going to go through with information on it. And in this particular instance, we've already done an alignment with this adjustable core over here. 10.7 megahertz comes out, goes into your IF chain. All you need to do now is adjust the minimum and the maximum frequency, or a frequency at the bottom end, frequency at the top end, with these two adjustments by moving this from zero capacitance or very low capacitance to its maximum capacitance. And once you've done that, you've actually told the system what frequency at the front end to listen to. You've told the system that whatever frequency is over here, subtracting 10.7 megahertz, the IF frequency, that's the frequency that should come through at the front end. And you are adjusting more or less to it with this trimmer or this half of the tuning condenser, and you can sort of fine tune it with these two tunable elements. Now there are other tunable elements on here, as you may see. Here's an example. There's a trimmer capacitor there. It's probably one of the ones that comes out the top. There's this interaction between these two coils, which I'm not sure you can change. I'm not sure about that. I'm just trying to look here. There's another tunable. Oh, there we go. There's another trimmable element, which you definitely do not mess with. Now, it's not too difficult to know what these do. This one here, for example, will tell the front end where to, what part of the band that's coming in here of frequencies it should let through to the RF amplifier. The point is, do not play with any adjustments on that box that the instructions do not tell you to play with. If you do, you run the risk of destabilizing this whole thing, and you'll probably, or you could end up not being able to get it to work again. It's happened to me once. Fortunately, I messed around with it so long that I finally started getting something. And then, of course, once you've got something coming through, you can play around very incrementally to perfect it. It took a long time, but it served as a very, very good learning experience. I'm a sucker for learning, and that one worked. It helped. But if you can avoid it, avoid it. So what we're doing here is really the same or similar to what we did with the AM section. Just as was the case with the AM alignment, the first thing you need to do is make sure that the dial is extending to the end. And I'm going across here, making sure that it extends. There's no mark at the end here. So we just have to see how far beyond the frequency range here, 100 megahertz, it goes. And on this side, it actually goes to 87 point, well, just below. It's going to the end. That's all we know. There is no marker to actually tell us where the end is, like we had with the AM bands. In some cases, you do get it, not in this one. So that's the first thing we do. Now, let's have a look at the instructions and see what it is they want us to do to adjust the RF alignment. First thing they say is that you set your signal generator, feed it into the antenna socket over there, and they expect your signal generator to be at 240 ohm output impedance, which is a little bit weird. Mine is 50 ohms, but regardless of that, I can't get 100 megahertz or anywhere near that from my Rygold. So I had to find something else to use when doing the FM alignment. And this is what I came up with. I found this device when I was looking for a RF signal generator. They can be quite expensive, and this thing seemed to fit the bill perfectly. Now, ELV produces these and sells them in Europe, and they actually sponsored a video that I did where I showcase the full functionality of this device. It's a stereo signal generator for FM. It's got all sorts of things. It actually does RDS. It does traffic signals. You can put all sorts of stuff programmed into here. You can program the output power. You can send a audio tone, 1 kilohertz and I think 100 hertz. So there's a lot of functionality in this little device. And as you can see, I've got some pre-programmed stations here, or settings here. The RF is on. 87.5 is the bottom end, and 108 Let's just check. Is it 108? Yeah, 108 is the top end, and you can adjust it. There's also an app that you can use on your PC to program this properly, and it can do stereo, mono, and all sorts of stuff. The point is, I use this thing all the time. Now, I know you can get some old signal generators that you can refurbish, and they can come out a lot cheaper, but this thing for me is so functional, so easy, that once I started using this thing, I don't really need anything else. And that's what I'll be using. Now, I do have a limitation here, and that is that 87.5. See that? That is the lowest frequency that it can produce. And as I said, 108 is the highest frequency that I can produce. And they actually tell us to start lower, which is a bit of a problem for me, but we'll work around that. So let's see what it is they want us to do. Well, they tell us to set the signals generated to 86.7 megahertz and adjust point D. Now, where is point D? Well, according to that drawing we have there, we can see D quite clearly. It is that guy over there, and that is the lower end of the frequency range of the oscillator adjustment. Now, here's my first issue. I don't have the capability with my little signal generator to produce 86.7. So I'm going to have to produce something else. As I mentioned, the lowest frequency I can go to is to 87.5. If I start going low, it rolls around. So I'm going to set this at 87.5, and I'm going to make the lower end frequency adjustment at 87.5, which means I need to put the dial pointer at 87.5 and get this signal coming through perfectly. So I've got this operational. I'm going to put it, well, let's leave it here. It probably will reach perfectly well over there. And let's see where it is. I've got this down at the bottom here, and I've got the volume enough that we can hear it. I want 87.5, and it's coming in, it's coming through down at the bottom here. There's 87.5. That's where I want it to be. And it's not. It's down here. Now, I've got to tell you, I've been playing with this already, but I'm going to set it there. In fact, I'm going to ride it up. I'm going to go down to where I just hear it. You can just hear it on microphone here. And I'm going to start adjusting it and then shifting the dial up to get it perfectly aligned. Let's see what we need to do here. Wrong way. There, it's going, so I'll move it closer. I know it's counterclockwise that I'm turning at the top. So I'm just going to get it to 87.5 and peak it there. That seems to be it. Ooh, that is loud. Okay. I've now aligned the bottom of the oscillator frequency range to coincide with the 87.5 that I can produce over here. So what is next? Well, next they tell us to set this to 100.5. I'm going to do that. And I'm now going to tune up to 100.5 and see where it is that we get it. And they tell us to adjust point C, which is that adjustment point on top of the can. Be careful, look at the drawing carefully, make sure you get the right one. So let's see where this is. 100.5. So I am approaching it. Oh, it's down. It's down to, there's 99, 99.5. It's about 99.8. So I want it up at 100.5, which will be about there. So let me ride it and adjust point C. When I say ride it, it's because I don't know whether I should turn clockwise or counterclockwise. So I put it just off where I'm hearing it. There's the tone. And there's a strong tone. I want it to go stronger as I get closer to there. So I'm going to adjust C, putting the screwdriver in there, and wrong way. Yep, that's that way. So I'll put it at 100.5 and peak it there and control the volume because this thing's really loud. $100.5, perfect, or nearly perfect. Maybe just a bit more. When I take the screwdriver off the core, changes slightly because you're putting a bit of pressure on it when you're adjusting it. So now we've got it at 100.5. Let's see something here. There's a station I know here. I don't have an antenna, but I know that it's receiving something over there, so it's pretty accurate at the moment. Now I've got to go to the bottom and do it again. But before I go to the bottom and check it again and make the adjustment on point D again, there's something I want to do here, which I always do on these radios, the ones that I'm going to use myself. Let me explain. My favorite radio station, the one I listen to very often, is at 101.6. Let's see if I can reach this. Let's see if I can pick it up. If I can, and I can. Right, it's done it by itself. Actually, what I'm going to do is I'm going to adjust the oscillator. So this point over here is 102. So at the end, over there, I want 102. Let me put that at 102. As you can see, it's going down. And the reason is I want to stretch the dial so that I can pick up my station at 101.6. So all I need to do is leave this at 102, watch that, or rather listen to the tone. It's still picking up some of that 101, but let me adjust this and peak it till I receive that 102. Whoa, that's loud. That is 102. Now, where's 101.6? Let's go back to 101.6. I want a little bit of leeway at the end, so it's not incredibly tight. It really made a huge difference over here. There's 101.6. It's now 101.6 is coming through at 100.5. So it's 100.6. So it's dropped at 1 megahertz, but it must have affected the bottom end as well. So let me check that. So I've set this guy to 87.5 again, and I want to see where it is that I receive him down here. Having adjusted the top, it'll make a difference down here, I'm sure. Not much. 87.4. That isn't bad. That isn't bad at all, and I'm going to leave it like that because what I could do is adjust it over there as well. But I'm going to leave it like that because I'm happy with that. And what I've done is I've actually messed up all the markings on here. You see, by trying to get 101.6 over here, I've actually, basically, I have to disregard what it says on the dial now because I've cramped the dial together. I've squished it together in order to extend it further beyond at that end, which means that these stations or the stations at these known frequencies will no longer correspond. This might sound counterintuitive because what we're trying to do is an RF alignment to get a perfect alignment with the dial. But believe me, there's so few FM stations nowadays that you'll know more or less where they are. And it's more important for me to increase this thing's capabilities in terms of stations by about 20%. There are 4 stations down here, 1 at the end. I can now get 5. So for me, that's more important than actually getting perfect dial accuracy. But that is a choice you make. You don't need to make that choice if you don't want to. I choose to make that choice for my radios. So that is the actual oscillator alignment done. We now have the actual front end to align as well. And that's got to do with sending frequencies, sending signals at known frequencies. Not quite at the bottom, not quite at the top, but a little bit inwards, and peaking the reception, peaking the input circuit, the antenna circuit, both the condenser, the capacitor, the trimmer capacitor, and the coil to get the strongest signal. So let's see what they tell us to do there. They tell us to set the signal generator to 88 megahertz. So 88. And now we've got to see where we're receiving it. I'll just tune up. Now what I'm going to do is I'm actually going to move the signal generator further away to weaken the signal because I want to tune the front end. You don't really go to a particular frequency. Now that we've shifted the whole scale, you go to where it's picking up the strongest. So we know that's 88. It's nearly there, but we've got it peaked over here. And I suppose we could use a multimeter or a meter at the output, but I'm going to do it by ear. So I'm going to move the signal generator away, or rather, actually what I'm going to do is I'm going to reduce the power. I'll make it as weak as I can. Of course, there's a station in the background. That's the problem with 88. I've got this little antenna on here. Maybe if I take that off, I've got just a piece of wire, and move this closer. What I did is I removed this, which was acting as a little antenna, removed that, put the signal generator closer so that I should be able to get only the tone. Now I'm supposed to peak it on this one over here, and I'm just going to listen to the tone, see if I hear much difference. It's going down. It's difficult for you to hear, but I can sort of hear it peaking there. So I'm going to leave it there. And the next frequency is 98. Do the same thing, put it close to the antenna at the back, and we'll tune. There's 98 there. Of course, it's receiving it slightly lower, but I'm going to try and get the highest peak volume out of this. And for that one, we're supposed to do the top one here, which is a trimmer capacitor, which I cannot see. Just a slight difference, not really much, but it's done. Well, my friends, the RF alignment for the FM is done in a rather convoluted way. Technically, this is a really bad alignment because I stretched the dial rather than trying to get it all exact. But that's the way I want it. It makes it a lot more useful for me, and that's the way it's going to stay. And that's the way it is in most of my radios. And this particular step, which is actually quite simple, is one that sometimes catches people out because it's a little bit scary if you haven't done it before, and if you don't know what it is you're doing, it can be a bit scary. The other thing is that a lot of people, most people can get their hands on an AM signal generator, but getting a good RF signal generator can be, well, prohibitive. It's expensive, and if you don't get an expensive one, or one that's substantial in terms of investment, it can be pretty useless. So there is a way to do it without a signal generator, and that is to use what can already be out there. And let me explain to you what I'm talking about. All you need is to know two stations on your dial, or know of two stations on your dial. And I'm quite fortunate in that I have two stations that are fairly strong, that are more or less at the end of these dials. Now, at the lower end, I happen to have one at 88 megahertz, which is pretty close to the bottom of the dial. And on that end, I've got a fairly strong one at 99, which is fairly close to the top of the dial. So if I don't have a signal generator, I can use those receptions, those signals, as indicators. In other words, if I look for the 88 megahertz station, and it is off the 88 over here, and I want to align it perfectly, I can do the lower end oscillator adjustment by trying to set it on that station. See what I mean? So you know it's 88, and you would adjust the lower end of the frequency band, you would adjust that trimmer or that coil, I'm not sure which one it was, till you get it on 88. That's your lower end oscillator alignment. Then you go to the top end, say 99, and in fact there's a station at 100 right here, but it's a weak station, but I could still use it. I would put an antenna up. Remember, you need an antenna in that case because you need to pick up the stations. So I would look for that station at 100 and adjust it till it coincides with the 100 on the dial. Then I'd come back and adjust the 88 again, go back and do the 100 again, and I could actually do the peaking of those last two adjustments we've done, the front end circuit alignment. I can actually do it on those stations by trying to get the best signal possible. And if it works, it works. You know, the whole objective is to make this thing receive well on one end and the other end. Now, if you're receiving well, it doesn't matter if it's another few millivolts of AC, of audio signal that you would detect on a meter. As long as you're receiving well, you've done your alignment. That's the whole point. So you have to remember that this is not going to be a piece of lab equipment. This is a radio that you should listen to. And if you're happy with what you're hearing, then you're going to be happy listening to it. So that's what you would do if you do not have an expensive or any kind of RF signal generator. For FM, they're a lot more complicated, a lot more expensive. And making one, I've tried to make one in the past and I didn't like the result. And then I found this ELV Sub 3 and that sort of spoiled it for me. What I'm going to be doing next is I'm going to be wrapping this project more as a normal restoration project than a back to basics series. If I find anything of interest that would fit into the back to basics concept, I will do another one or maybe even 2 videos on this. Otherwise, I'm going to finish this radio. There are a few that have been sitting around waiting to be worked on. I'm really anxious to get into those, and I'm sure some of you are too. So once again, I hope you've enjoyed that. And if you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon and PayPal. Links are in the description below. Thanks for watching. Bye for now. And most of all, stay safe.